Welcome to the Trend Detection Podcast, powered by Siemens.
Hello and welcome to Trend Detection. Today we are joined by Dr. Chris Smith to discuss the topic of predictive maintenance versus condition monitoring. So, hi Chris, thank you for joining us today. So to start off, a bit of background on your role at Siemens.
Yeah, no problem. So I work in the Senseye business unit and I work in the delivery department as our implementation lead. So I look after our best practice for deploying our technology, our predictive maintenance software into our customer base. So really I'm looking at not only kind of how to make it as streamlined as possible, but also how to support our customers in their predictive maintenance journey. And in terms of my background, I started life doing a PhD in wind turbine reliability before moving into the rail sector, working kind of asset management, maintenance analyst, maintenance support roles before joining Senseye about 5 years ago. And now we've been acquired by Siemens a little while ago now, hence I'm in Siemens.
That's great, thank you, Chris. It's really interesting to hear how diverse your background is, and it makes you the perfect person to speak to about this topic today. So today we are discussing predictive maintenance versus monitoring. So, as you'll be aware already, often the definitions of these terms can cause some confusion. So it'd be really good to hear your explanation of each term and what the differences are between these two terms.
Yeah, absolutely. So I think when you're looking at these as a kind of, you can't really look at these as a comparison as more as one kind of leads into the other. So condition monitoring is very much a technique of capturing machine-related data that would provide some sort of insight into the condition or the health of the machine. And so that could be anything from like vibration, looking at oil analysis, kind of oil debris data, could look at the pressures across a pump, etc., and effectively tracking that over time in some way. So either periodically using kind of a handheld device or online and continuously monitoring. Predictive maintenance is much more about how you use that data to impact your actual maintenance strategy. So what predictive maintenance is trying to do is use condition monitoring data and other sorts, which I think we'll talk about a bit later, to determine when you potentially need to do some form of intervention with your assets. So taking what the condition is and that data and looking ahead as to what that might lead to. Now, to note, that isn't to say I'm going to tell you exactly when you should change your bearing, on the 21st of January 2025, because of all these different signatures. To a certain extent, that is possible if you've got enough information, but in the real world, for the vast majority of assets, you haven't got that kind of granular detail that you need in order to give that prediction. So if you're wanting to look at predictive maintenance at scale across a vast number of assets, we're much more looking to predict when you're potentially going to need to intervene, maybe provide some diagnosis about that as well if we have enough information. But then it's effectively giving the maintenance end user the ability to say, okay, I need to go investigate this further. And I know which of my 2,000 assets, which 10 I need to go look at the next maintenance window. So to give you as an example, if we look at a smartwatch with a heart rate monitor on it, which I have, and not a really fancy one, but I do have one. The condition monitoring part of that is tracking that heart rate. And maybe you have other metrics on there, like your oxygen intake or something like that. So we're looking at some metrics that we're tracking over time. What predictive maintenance would do at that point, or by applying kind of predictive maintenance techniques, is to track that and determine, is that getting worse, and at what kind of rate is that getting worse, or is it absolutely fine? If it starts to get worse, it gets higher when I'm doing the same kind of exercise, or my oxygen levels were reducing, that is an indication that my health is deteriorating. Based on those data metrics, it might not be able to tell me why but it can at least say there's a potential problem, and it's effectively predicting that if things carry on as they are, that I'm maybe in a kind of a worse health state. And so at that point, I see it and I go, okay, it's now time for me to go to the doctor, who may then use some more kind of sophisticated equipment, like an ECG machine, to indicate and diagnose what that problem might be. Equally, if it's early enough, I may actually change some simple things in my life, such as eating better, exercising more, and actually see that the trend reduces again. And if I kind of flip back to the machine world, that might be just doing a simple lubrication at the right time to bring vibration down. And so I think there's a concept, predictive maintenance, that will tell you exactly when something's going to fail. And in some circumstances it can, but actually in a large number, it's about just giving you really early warning that you need to do some sort of intervention to avoid a much worse fate later.
That's great. Thank you, Chris. That's a really insightful definition of the two terms, and I really like the kind of health, heart analogy you've used there as well. I think that's a really clever way of explaining it and kind of being able to visualize it as well. So that's great. Thank you. So moving on, obviously for every business, kind of the main KPIs are usually to save money and improve. So it'd be really great to hear your insight on how you feel that these two approaches can save businesses money and improve their overall efficiency.
Yeah, absolutely. And I think the best way to do that would be to compare it to what the alternatives are. So for simplicity's sake, I'll compare it to kind of the two main other maintenance strategies that you may see, being reactive and being time-based preventive maintenance. There's a number of others you could do as well, but they're kind of the two main ones you tend to see. So reactive maintenance is often seen as kind of the bottom rung of maintenance, where effectively you just wait until the asset fails and then you intervene. Now, I don't really like this kind of, you sometimes see these steps of moving up the kind of almost like the maturity of your maintenance, because actually there are circumstances where reactive maintenance is a perfectly reasonable maintenance strategy. For example, I have a computer, as most people do, has a fan. I don't periodically change the fan. I don't periodically lubricate the bearing on it. I probably should clean it more often, but I don't really bother, because actually if that fan were to fail, the cost impact is very low. It just means my computer will get too hot, so I just make sure I turn it off and I'll go buy a new fan. The outcome doesn't warrant me making any more investment in time, money, or energy to avoid that failure. However, if you're running a production line, and even on your less critical machines, it could cause 2, 3, 8 hours of downtime if something goes down, like a fan that's cooling something there. Reactive maintenance may not be the best approach, because when it fails, you're going to have unplanned downtime, so your loss of production, and particularly if you're capacity constrained or you're selling everything that you make, that is just money down the drain. But also the potential damage that has happened is going to generally be larger. So when I was working in the wind industry, small failures could lead to catastrophic outcomes if they weren't captured early enough, where so a problem with a gear tooth eventually could lead to an entire blowout of an entire wind turbine. You don't want to wait until that happens. And so just reacting can be really expensive, and it also can take longer to repair. You have to get the specialist staff in potentially on overtime. It just gets really expensive. Doing time-based preventive maintenance avoids not all, but some of those catastrophic events, because what you're looking to do there is, if I intervene with this asset enough, I will capture those failures or those kind of them getting worse, or avoid them by doing some sort of greasing or cleaning or realigning, and that will keep the asset going longer, and I'll avoid those major events. Now, that kind of time-based maintenance is often based on manufacturer's guidance or on experience. And typically you're looking at the mean time between failure. So you're basically looking at a population and saying it tends to last for, let's say, 7 years, so we'll replace it at 6. Now, that's great across a population, but when you look at an individual asset, it may only last 5 years, or it may last 10 years. And so by you intervening at 6 years, you're either not avoiding that event, or you've actually lost a year's worth of life in that asset. And so it's a good kind of catch-all, but it isn't an optimized solution necessarily. Looking at predictive maintenance then, where we're looking to say when things are getting worse and you should intervene soon, you're taking away some of that guesswork. So you're now saying, well, instead of just going in at periodic points, we're now saying, well, actually, this asset's absolutely fine. The metrics are all saying it's running cleanly, and we're confident we'll get to the next maintenance window. Then you actually reduce the amount of parts you use, the amount of ancillaries, man hours that could be used elsewhere. And equally, if it doesn't make it to that point, then you're going to have a failure, and you have the same problem that you have with reactive maintenance. And so if we can make a more accurate assessment of when this asset is actually going to fail, you have a much more optimized solution. And that really is based on the cost of your downtime and the cost of it is to repair and the people that you have to repair it.
That's great, thank you, Chris. That's really essential information and extremely useful as well. So thank you for providing your insight on that topic. So moving on now to looking at data, it'd be really great to hear your thoughts on what types of data are actually used in predictive maintenance and condition monitoring, and how do those types of data differ?
Yeah, absolutely. So I think I mentioned earlier that predictive maintenance, or any effective predictive maintenance strategy, is going to be using condition monitoring data. And so really the types of data that you use for both of them is very similar, but predictive maintenance tends to use a few other sources as well. So condition monitoring data, we're very much looking for information about the machine. So that could be things like vibration, oil, debris, current, etc. So it's physical metrics about the condition of the asset, and that's critical for predictive maintenance as well. But predictive maintenance can also use past failure events, so information about the history of the asset, to give more precise predictions of diagnosing what the problem might be, but also how long you have until you need to intervene based on past experience. So it doesn't need to rely on that, and actually our technology doesn't. We assume no prior knowledge in that way, but you can supplement it with kind of maintenance data in order to do that. It's also really key to add that in condition monitoring, but particularly in predictive maintenance, more due to the way you set it up, is operational state for your assets is really important. So if you're monitoring the condition of an asset, but the operation changes all the time, you've got two options. Either you make sure that you're only capturing data at the same point in the cycle, or when it's producing the same thing, etc. Or you also ingest information about the state of the operation. So for example, if you've got a fan, it's connected to a variable speed drive, or like your desk fan where it has a number of buttons on it to change the speed of it. If you press the higher button or you increase the speed on your fan, it's going to be blowing more air, so it's going to draw more current. We don't want to alert someone when the current increases just because you've turned up the speed of the fan, but that's very hard to model, to say the difference between when a fan is increased in speed and when it's deteriorating. Provide the right information and you can get a much more accurate idea of the condition by saying, actually, we also provide the speed. The current went up, but the speed didn't, indication that there's degradation of the asset, or vice versa. We asked the speed to increase, but the current didn't increase. There may be a control loop problem, or actually the fan's blown off and it's actually not doing anything at all. So yeah, that's kind of the three main data sources you need for predictive maintenance, which is the condition monitoring data, the operational data, which condition monitoring also uses, but depends on your setup, and your maintenance and history data of your asset.
That's great, Chris. And I'm guessing in order to, to have the notifications feedback, the most accurate, forms of information, that there might be things that customers can do on their side to make sure that the data is prepped in advance. So just making sure that it's all streamlined. Is there a couple of tips you have just for customers, just to make sure that the data is ready before feeding it into a system?
Yeah, absolutely. I think having the opportunity to run a small sample of data, find if you personally or someone who you know is good with plotting up charts, doesn't have to be complicated, and talking with kind of your machine experts to understand what are the normal operations of your machine, to be able to say, well, actually, and also determine what data you already have available, to say, okay, here's our line. It typically runs 5 different products, and we change the operational speed of the line from time to time depending on demand. That is all critical information to know. You don't necessarily need to plot it up, but if you can, fantastic. To see how that impacts any data that you do have. Because that way, when you're starting off, you say, oh yeah, we've got current, we've got vibration, or we could install vibration, but we know that we run the speed at different speeds, so we'll make sure we need to find a source for that data. Often variable speed drives will have it, or an operational kind of overall SCADA system may have it. And so you just know what things you're considering. And then if you go into a bit of a deeper dive with someone, for example, in our team, we'll look and say what actually matters and actually what data doesn't matter as well. But if we at least have kind of a starting point, you'll accelerate that journey on particular machines much more quickly.
That's great, Chris. That's super helpful information. Thank you for elaborating a bit more into that as well. So moving on to tools and technology, it'd be really great to hear your insight on what tools and technology are commonly used in each method, and how those are implemented on a wider scale as well.
Yeah. So first bit being the condition monitoring, and a lot of people hear the word condition monitoring will immediately think vibration, and they're not wrong. Absolutely not wrong, because it's one of the most kind of tried and tested ways of monitoring equipment, particularly with bearings and gearboxes. But really, as I mentioned earlier, any sort of data that will change in the absence of known stimuli, such as a change in operational state. And so that data can be sourced from sensors, so vibration sensors, maybe you have current sensors, pressure sensors, you name it, there's probably a sensor for it. But you may also look at drive data. So if you've got variable speed drives or controlled by PLCs, etc., you can get a lot of metrics from your drives, or even your PID control loops, or timings of actions. So if you've got actuators that move from point A to point B, the time can be really useful if it's kind of an open loop control, etc. This is all I could go into a lot of detail about this. But fundamentally, we're looking for data, and the technology is generally sensors or connected IoT devices, or that could be connected. From the predictive maintenance side, you could do it by hand if you really wanted to. You could get the data from your sensors, plot it up in your favorite plotting package, or even on a bit of paper, and seeing where it's going and saying, well, actually, that's trending upwards. Looks like in about 2 months it's going to hit some sort of important threshold, or it's getting worse. We don't know why. We should go investigate. You could do it that way. In reality, some sort of software is going to be really useful for that, and we use AI to be able to look at that data and look for unusual behavior at scale, because it can learn what's normal behavior on any machine, on any kind of data set, and look for that unusual behavior without much intervention from ourselves.
Yeah.
And that just means it's practical, and it's practical at scale. So you move from being able to look at 50 assets in a team to 2,000 assets or 3,000 assets or however many it might be. And then the final bit of the puzzle there would be kind of looking at IoT stacks. So we're a cloud-based technology. So we need the data from the shop floor to the cloud. And so there's an IoT element to it. And, what we tend to see is kind of two approaches to that. There's either putting all data available into a kind of a historian, a cloud-enabled, web-enabled historian. Either it's on-premise and you can get to it via the cloud, or it's in the cloud. Or edge technology is becoming more and more to the fore about just directly connecting from shop floor to edge to cloud. And they're the kind of main technology pieces and tools that you'll see within the space.
No, that's great. Thank you, Chris. That's super interesting and really gives a good general overview, as you said, of what technology pieces are, included in this area. So that's super helpful. So moving on now to a bit more of an industry focus. Would you be able to shed a little bit of light on specific industries or situations where one approach is better than the other? So is predictive maintenance more suitable for certain industry, condition monitoring more suitable for another industry? So it'd be really great to hear a little bit more about that.
Yeah, so I think in terms of, like I mentioned, you need condition monitoring to do predictive maintenance. So it's whether you then move from a kind of condition-based maintenance strategy to predictive maintenance, or you're just using the condition monitoring as a supplement to a preventative maintenance strategy, etc. I think that's kind of where the question's going, or that's how I'm going to take it. And I think, so I think it all really comes down to your business costs. Your cost of downtime, what it costs in production loss, cost to your equipment, etc., and the cost of maintaining that equipment. PDM will cost you more than a reactive maintenance technology. PDM will cost you a bit more than just a pure condition monitoring system. And so, there needs to be a kind of a justifiable reason for those costs. Now, in general, if you're running an operational line, and your cost of downtime is anything more than £2 an hour, then you're not going to use reactive. You're probably going to use something else. Whether it's more cost effective than preventative maintenance really does depend on how tuned that preventative maintenance strategy is. And I would argue in most cases, it won't be optimized. And so let's say, I'll paint it another way, if you have no failures whatsoever, the benefit of predictive maintenance really is to optimize your preventative maintenance strategy so that, if you've got no failures whatsoever, it might be perfectly optimized, in which case there's no room for error, and so there's no benefit to using predictive maintenance. In reality, most people are probably over maintaining their equipment in that scenario, and so the cost benefit analysis there is, if we optimize our maintenance strategy by using predictive, then we'll reduce the amount of parts we have in store, we reduce the amount of spares we use, and the amount of kind of third-party contractors we need, etc., etc. So then it becomes an assessment of, can you optimize your preventive maintenance strategy with PDM? And if you think there's enough in there to be able to say to pay for the software or the extra hardware, etc., then absolutely. If there's downtime that you're having, then and it's costly, then predictive maintenance is almost a no-brainer. As long as those kind of failures aren't things like lightning strikes or kind of people damaging equipment maliciously, etc. Those kind of one-off instantaneous events you're never going to be able to predict. But if you're seeing lots of failures that are clearly probably quite predictable, then predictive maintenance would be a good use. And then in terms of specific industries, if we look at heavy industry, pharma, automotive, they have generally a high cost of downtime because they've got a very valuable product, or their equipment is very expensive, then it's generally you're going to go down that predictive maintenance route, and that's what we see time and time again. In other industries such as food and beverage, you generally have to be a bit more selective about which machines you may deploy technology to, because the margins are smaller. It's not to say there isn't opportunity, and we do see opportunities in food and beverage, and we have had good successes there. But the study about the business case just has to be a bit tighter when we're working in that space.
No, that's super interesting. Thank you, Chris. It's really interesting, to kind of know which industries are gonna benefit more from each approach, and some of the external factors that can cause issues. In terms of damage and weather and things like that. That's something that you might not initially think of. So that's really interesting to hear about. So just moving on in terms of kind of like human workforce and like factory staff, as you know, sometimes there's a little bit of resistance with them taking on technology, as you know, because it can cause a little bit of unrest. So it'd be really good to hear your thoughts on how these approaches affect the general workforce within manufacturing and the required skills as well. Is it something where all staff feeling like their skills are being replaced, or is it coming hand in hand and actually supporting them on a an overall ability? So yeah, really great to hear your thoughts on that.
Yeah, absolutely. I think when people hear condition monitoring or predictive maintenance, I don't think they tend to see much risk. I think AI is the artificial intelligence bit is the bit where people get nervous. When you see it with people talking about self-driving cars, self-driving. Well, we have self-driving trains already, but cars. When robots are replacing people in factory floors, etc. So I think the AI piece is the bit that people get more nervous about. And really what we've seen is that there hasn't really been any evidence to say that it replaces people. And in fact, if anything, it actually enhances people's roles and their kind of how they're viewed within the organization. I've lost count of the number of people who've deployed predictive maintenance with AI in it and end up getting promoted because it has such a good impact. And really, what I say, it's not a job killer, but a job enhancer. So you become more valuable to your organization by avoiding huge costs. If at the end of the day, we're just a tool, the product or whatever product you use is just a tool. It still needs people to use it, and we still need that wealth of expertise that the local maintenance staff have in order to actually benefit from using this kind of technology. Other things that we notice as well, there's the aging workforce, and people are seeing this as an opportunity. Businesses or even maintenance staff are seeing it as an opportunity to embed the knowledge of kind of that aging workforce into a system that makes it accessible to future generations. So you don't lose your person who's been there for 30 odd years, and suddenly you've lost all this knowledge. But it's been captured somewhere and then is accessible to someone who's learning the role, and it's still important to them. So the system has the information, but it can't use it. It doesn't have arms and legs and the skills to repair the equipment. It's just simply saying, actually, this is what it potentially could be. I'd also say that the profile of the end user changes slightly as well. So in order to effectively use any kind of predictive maintenance product or condition monitoring, you need to have good data literacy skills. I would certainly say not a data scientist. I think there's often a misconception that you need to have a data science degree to be able to look at this kind of data. Actually, we work really hard as a team, or the product team do certainly. The delivery team supports this, and looking at a UI to make it as accessible as possible to the maintenance teams that use it. They don't want really fancy statistical plots. They don't, and in like different ways of looking at the data, etc. necessary. They want to know, do I need to intervene with this asset? And us want to provide that information to them. But it does change the profile a little bit, or certainly creates a new profile within the maintenance organization, where we have people who are savvy with data can work hand in hand with people who are really good at understanding the machines, etc.
And again, that's great, thank you. And I can imagine that's really reassuring for listeners and business as well, just to know that, it's not a platform or a tool that's looking to replace, it's looking to enhance, which I think absolutely. is a really reassuring thing to hear. So that's great. Thank you for providing more information on that. So we're just coming down to our last couple of questions now. So moving on, as you can imagine, implementing any kind of new tool or approach, some businesses are going to face some new challenges. So it'd be really great to hear your insight on what challenges businesses might face when implementing predictive maintenance and condition monitoring, and how they can overcome them.
Yeah, absolutely. So I think these kind of challenges come in three main categories, which are technology, business case, which we've spoken a lot about, and cultural. So I think the technological challenges in some ways are the simplest to solve, not from a complexity perspective, but from it's a more straightforward view of what you need to do. You need data, and you need it in the right place, and there are products and tools in order to achieve that. You of course get challenging scenarios where data is in proprietary PLCs that can't be accessed, so a different route might need to be put in, or different sensors. But fundamentally, there are products that can solve those problems. Here at Siemens, we have a wealth of those kind of products that can support that. And so I would say that that's a project, and it's a challenge to overcome, but it's certainly doable. The second, which we've spoken a lot about, is that kind of business case. Many treat deploying predictive maintenance as a data science project. So they want to see results, and then from a kind of a small study that is quite exciting for a few people, but actually to the business, because you've done a small amount of assets, you've done it offline, it doesn't really impact the business, and thus actually no one's going to want to take it forward. And so in that scenario, the challenge is actually you need to do a deployment, and you need to do it at a scale that is enough to impact the business, impact the maintenance strategy enough so that you see the value and thus actually want to roll forward. And so in that case, it's moving away from this as kind of something to test to something to deploy. And the third bit is cultural. Getting people to use the technology is absolutely paramount. As I mentioned before, without people, then we're just a few shiny boxes and a bit of software that looks quite nice. It doesn't really do anything. You need someone to actually access, engage, and use that data to actually impact the maintenance, reduce downtime, reduce unnecessary maintenance costs. And really what's key there is you need to make it as easy as possible to want to pick it up. It shouldn't be a real hassle. And there's also needs to be some pressure, maybe not the right word, but encouragement from management to say, this is the new way we're going. We want you to be empowered to use the technology, etc. And people who are going to use the application and people who are going to benefit from it need to be involved early in any sort of delivery and implementation of the products that you're going to use, so that they feel ownership of using it. And that's really key, not just kind of throwing it to them saying, right, off you go, new bit of tech, just use it. People will just put it down. We're looking to solve problems longer term. People have a lot of problems day to day. They're going to focus on the day to day, even if something's going to actually reduce their day to day problems later. So there needs to be an encouragement to change a mindset there, and getting them involved early should help with that.
That's super interesting. Thank you, Chris. And yeah, I really like how you're saying important to have stakeholders on board from the early onset, because it's so important in kind of influencing a mindset that this tool is here to help and to kind of work with the human team and kind of be connected together, which is the most important thing. So thank you. That was a really interesting answer. So moving on to our final question. So again, we're touching on the topic of artificial intelligence again, which has a lot of discussion around it. But it'd be really great to hear your insight on how does artificial intelligence and machine learning play a role in predictive maintenance and condition monitoring. I know we've kind of touched on this already, but it'd be good to just have a kind of a summary of it, just to kind of end the episode.
Yeah, absolutely. I like to think of AI as, and maybe other people disagree with it, but it's taking things that we could do if we had a very, very, very long time and just doing it really quickly. And, maybe not entirely accurate saying that, because, you look at things where they're looking at deep learning, etc., and it can look for patterns that we couldn't see. Perhaps over millions of years we could, but effectively it's speeding up what we can do. And so what we use it for in predictive maintenance is to be able to take vast amounts of data and look for unusual behavior within that data that we can then present to the end customer. And like I said earlier, you could do that manually. You could have lots and lots of people looking through that data day on, day out and saying, well, that's unusual, that's not, etc., etc. It's not cost effective, it's not efficient. It's much better to use AI to do something like that. So that's what we've been using it traditionally, as much as you could say AI is using it traditionally. But the second bit that we're actually kind of much more experimenting with at the moment is how to interpret the results. So we've been looking at large language models, etc., to see if we can summarize the results of what our product generates into a more human readable output, particularly to support accessibility of the outcomes. So you don't necessarily, we talked about people don't need a data science project background, but actually we want to reduce that barrier so that they can understand the information that's been given to them and then action it. And so they're the kind of the two elements that we're using it more. Our bread and butter, which has been looking at the monitoring that data at scale effectively, and moving much more into much more readable results.
No, that's perfect. Thank you, Chris. I think that's a great outlook on the topic of AI as well. So that's super interesting and informative, again, for our listeners. So thank you so much for joining us today. I think that wraps up all our questions and the episode for today. So again, thank you for your insight and all your expertise. It's been super interesting to hear, and hopefully we'll have you back again on another episode soon. So thank you for listeners for tuning in, and we will be back again soon with another episode. Thank you and goodbye.
Please like and subscribe on all major podcast channels, and find out more about Senseye Predictive Maintenance at Siemens.com.